Next up, we have Mr. Ramesh Kumar. He's senior engineer at CrowdStrike, who will deliver his talk titled Introduction to Containers and Kubernetes. So, Mr. Ramesh here has been working in the cybersecurity domain for about 5 years now, with specialization in container and cloud security. So, before this, he wrote a tool called REST. It's a REST API validation tool. He also wrote a few other open source tools like Allrounder, Templist, and more. So it is a great pleasure to welcome you, Mr. Ramesh.
Hey, hi everyone. Hi Ritvik and all the team,
Hello.
all the Abhita. Can you hear me?
Yes. You're audible. Go ahead. All the best.
Okay. So thank you for giving a brief intro about me, Ritvik. So yes, once again, I'm Ramesh. Work for CrowdStrike in cloud workload team. So what we do is that we protect different cloud workloads. Cloud workload, it means that different kind of containers, cloud itself, the portion management, and of course, when it comes to containers, there is a lot of things about around Kubernetes, uh, uh, and also things like ECS, Fargate, and of course, the fast space, I mean, the function as a service kind of things. So, for example, Lambda. So these all comes into cloud workload, and we write solution, right, and we deliver product so that industry can use that and secure their assets in the cloud. So that's what we do. I'll start sharing my screen. I'm not going to talk really deep about how how the cloud workloads is being protected. I'll give a brief intro. Uh, just a second. Okay. So here we are. Okay, we already. So the agenda here is that we will be talking about uh, some brief introduction about containers and images, Kubernetes, cloud, and how those can be protected. There will be a separate deep dive into security. Of course, it's a security conference, and we have to talk about how this can be secured. So this session will just cover the basic and the high level overview about how these can be protected. The deep dive will be happening tomorrow by my colleague Ajit Tumale. So 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 it's just a brief introduction about these all things, because before securing these all components, you need to understand them very well from a very fundamental level. What are these and how these are being used in our day-to-day development, deployment, in production. So we need to understand them very well. I understand that many of you already know that these all things, maybe quite well, not quite well, but anyway, it's a good idea to get through these all things to understand these all, so that when we are jumping into how to secure this, we should have a great fundamental in the base. So, okay, so we'll be talking about these all things. So let's go. Okay, so if anybody has seen any video or conferences about the containers and Kubernetes, the very basic thing people you would have seen that they take example of seaports, so and all. So I don't know if people can respond here. So how many have you been to a seaport? Okay, I'll not consider that there are responses going forward. I'll maybe. Okay, so there are cases that I have seaports are example are something that we don't usually get to know because let's take a very general example. So how many of you have been to a kitchen? Of course, we daily go to kitchen to sometimes to cook, sometimes to prepare snacks, things like that. Okay, so why I'm bringing this seaport and kitchen and kind of thing is because this is where this is where we can relate container into in our day-to-day life, and those are not uh, exactly same, but it's good for it's good to get a close reference into our day-to-day life, and that's what I am trying to correlate here. So kitchen, of course, has containers. We have containers for sugar, pulses, and different kind of seeds, blah blah blah, so many things. I will not talk about these all things. Okay, so yeah, I'll be talking about Docker as well. Just we'll be going through after a few slides. All right. Okay, so why kitchens? A kitchen has a lot of containers, and containers in cloud and containers in kitchen are very close, and we'll be talking about it how this. Okay, so what are containers? These are basically isolated. Even in cloud world, in cloud workload world, the container are isolated, and even in kitchen we have isolated things. For example, there's a tea container which only had teas, so they are very much isolated. They are packaged as well, so of course you'll not leave tea in a open thing, right? You'll put it in container so that it can be used for a long while, and same goes for containers in cloud workload as well. So these are packaged with different kind of executables, file configuration, blah blah blah, and so many things. And that's what container is. So it's an isolated packaged environment of running a set of one process or maybe multiple processes. So these run in an isolated environment. And what these isolated means that in Linux term is that they are namespaced by volume, namespaced by user, and so many things. There are different kind of namespaces, and the network namespaces, host namespaces, and so many things. So by namespaces, namespaces comes from the Linux fundamental. So Linux itself has namespaces, and you don't really need containers to start in an isolated environment, but containers provide you pretty nice uh, user-friendly way or quick way to spawn a process running into an isolated environment or isolated namespaces. So yep, and package I already talked about that. It has different executables based on what image is started with. So talking with image, let's talk about how this image can be brought up. So many of you, if you don't know image, so this will be another very simple example to our day-to-day life. So we all would have bought pulse mixture. So let's say you have bought a pulse mixture of something like one kind of pulse and another kind of pulse and so many things. And consider this as an image. So what happens is that image tells you what are the contents. I mean, of course, in the packet, you will see what kind of pulses are there. And the same goes for the images in the cloud as well. So image has a configuration which has a set of layers, of which layers this image has been built up. So those layers, each of these layers are basically have a set of executable set of files, and it is based upon something like overlay file system. And of course, it tells you how it has been packaged. That means that what is the configuration of the image on which it has been built. So configuration says that what is the users need to start with, what is the environment variable, what is the volume mount, and so many things. So these will tell you these all information. So so image is a collection of files with some configuration, which any kind of orchestrator like Docker, Kubernetes takes it, and they use this configuration to start a container. I'll talk about these as well in the coming slides. Okay, so why images and containers? Why we are using this? Why we do not simply use simple? I mean, I'll just write a program and start on my machine, and that's it. That will also start a process, right? But why we use images and containers? So here's the very major reason. There are multiple reasons, but this is one of the major reason is that we write so many different kind of applications. If you can see my cursor, okay, we write different kind of applications to run on a machine. Let's say we have written a Node.js, MySQL, Angular, and Redis, and these all are used in pretty frequently in our day-to-day productions. Now, each one of them, of course, need different kind of libraries. Both are written in different programming languages, or even if they are written in same programming language, they would need a different set of dependencies. Now, there may be that one of the library in Angular would be using different other library, and that internally use other libraries, and there would be something like uh, one of the application need to use version 1 of the same library, and another application is using version 2 of the same library. So if you are planning to have them on your single machine, which one would you have? It's like it really get complex. So let's say you have hundreds of applications and you have thousands of libraries and dependencies. It becomes very complex to manage all those. So what's the good idea is that each application need to run in a separate container, and they should have their own set of libraries and dependencies with their specific version whatever they need, right? So apart from being isolated and packaged, they also are packaged, of course, with all set of libraries and dependencies, so that they don't conflict with other applications. Another good advantage that the developer whoever is building that image should have same set of same set of library and dependency as of the developer machine as it would be in the production. So me as a developer, what I can do is that I can write my application, test on my local machine, I mean with the image itself, and that is guaranteed to be run on the same image is guaranteed to be run on the production. So there is nothing like, okay, this feature works on my environment and nothing else like that. So we typically hear a lot that it works on my environment. So it's like a simple excuse for it's like a funny way to say that, okay, this is a excuse that it runs on my system. So bringing with this, it's nothing like that. In all, nothing like one can make an excuse that it works on my system, because if I'm writing an application, I can prepare an image, I can test it, that is guaranteed to be running the same way in the production. So that's the major reason. And of course, when it comes to operating system, the hardware is of course same, and the operating system is all the containers, by the way, are based on Linux. By the way, there are Windows containers as well, but we'll not be talking about that. Cloud is mostly, you can say 99% is using the Linux containers only. So when it comes to operating system, they use the same operating system. All the containers use the same operating system, Linux. Though if you think about Linux has a different varieties, or what do you call, distros like Fedora, Ubuntu, Red Hat, XYZ. So those does provide you set of different libraries and tools, but underlying operating system is Linux only. And to be more specific, Linux has a kernel. So kernel is what the operating system is, and different kind of distros use that kernel to make their own variant of so-called operating system that we use in our day-to-day life. But Linux kernel is what's the main operating system is, and this is shared across all the containers on one machine. So kernel is being shared. The benefit of that is that it requires very less memory, very less CPU, and of course, since it's namespace, kernel can manage all those things quite well, because these are the kernel features only. Okay, so that's why we can use. By the way, running with containers and VMs, we'll be talking about that comparison as well if anyone is curious about in the later slides. So let's move forward. Okay, so these are all things I spoke about. Now, I mean, one thing, dependency hell. So that's we just spoke about. And we also spoke about, okay, we need to run the same image in the production, exactly in the same environment and everything that can be facilitated with images and containers. Scalability, of course. When think about, if you want to scale it to, let's say you want to horizontally scale a different number of, based on the load that you are having. So let's say if you're running on a single system, it will be difficult for you to scale it horizontally, because both are using, all of the processes would be using on the same machine. And even if you think about running on a different machine, you would need a separate kind of some other kind of tools, which is like which is not so on which you have to put so much effort. With containers, what you can do is that you can schedule a set of containers to run on a single machine, a set of container to run on a single other machine, and so on and so forth. And that's what Kubernetes does. I will talk about it. But scalability is what you can achieve. You can spawn thousands of containers. You can scale up, scale down as per your load. And containers and images provide a great underlying infrastructure for this. And of course, since they are namespaced, they are isolated. And this provides security from inside. I mean, from inside means that process itself cannot come out of being namespace. Once we namespace a process, it is isolated there. And though there has been some you can say breakouts in which you would have heard of container breakouts. So it's just that the configuration of the image was not proper, and the underlying security was not in place. So, but ideally, the containers are meant to have isolated and secure from inside. From inside means from the process perspective. They cannot see the file system of the root or the other containers and all. They cannot see other processes in the other containers unless their process namespace is shared between those containers. So their namespace can be shared between two containers, and by which they can see what all other processes are running. So namespace can also be shared, by the way. But by default, let's consider that the namespace are not shared, and they will be perfectly isolated and secure. And again, from the process perspective only, not from the outside. I mean, of course, if I'm a root user on a machine, I can go into any container and do whatever I want, right? But here we are talking about from the process perspective. So let's say whenever a process is compromised from outside. I mean, let's say that process is having something like an injection, SQL injection and all. In that case, process is doing something, right? So if we place the process inside a container, the capabilities of that process get limited. They are namespace. So that way it provides that kind of security. Okay, so enough we have talked about images and containers. Let's talk about CI/CD pipeline. Okay, again, we'll take a very real life example of a coffee factory. So coffee factory, of course, what happens in coffee factory is that it collects the raw content. It does the filtering that, I don't want a bad coffee and all. Okay, I builds it. Builds means that the coffee need to be dried out, other kind of processing, which I'm not going to talk about. But yeah, so those are the builds, and of course I have to package that in some containers again and things like this, and then we have to ship that. So this is typically what happens in the coffee factory, and something similar happens in CI/CD pipeline as well. CI/CD means that continuous integration and continuous deployment, and this pipeline helps to build image and deploy just almost similar to what happens in the coffee factory. Let's talk about it from a very high level diagram here. So so code is the raw content, like we talk about the raw coffee. So code is here raw content. People used to commit it, and maybe recommit it, and so on and so forth. So what happens is that after that code is committed and pushed to the let's say Git or wherever you are hosting your code, what CI/CD does is that it builds the code. Builds mean that you would be using some kind of building tools, Gradle or anything like that. There are different build tools for different kind of languages or things. So it builds that based on what kind of application is it. It runs the unit test. It does the integration test. Unit test is something that you would run, test the functions, the units of the application. Integration test is when one unit or one subsystem talks to another subsystem. So that's the integration test, just for the information. So CI pipeline means that whenever a code is posted, I want whenever code is posted or any kind of similar event, I want to build my code, I want to unit test the code, I want to integration test, and once these are good, I'm good to deploy it. And these all should be automated. So the prime motive of CI/CD pipeline is automation. Everything should be automated, and making it automated also makes it less error prone, and it's make sure that unit tests or all kind of tests are good, and my application is healthy and everything like that. So in the CI pipelines, I will do these all things, and once this is good, I'm going to build an image out of the code from the Docker file or whatever. So once we have built the image, it will go to the review. Okay, this is going to be published. So the review would be like, okay, I have a new image coming into picture. Is this allowed to be going into production or not? So once this goes into production, one of them is review them. It can be automated as well based on some set of benchmarks or things like this. Then it should automatically go to staging, and after some time in staging, if it does not find any issue or things like this, it will automatically go to production as well. There are ways people prefer in the industries that we can promote it from one stage to another, and manually or by automated. Let's say in an automated way, let's say in staging, if image is running for, let's say, 2 days, 3 days, or maybe 7 days, it will automatically go to production. Or maybe on a specific days, let's say every Friday I have to make a release. So in that case, last Friday, one of the staging will go into production automatically, and there is no manual intervention is involved. So this all is automated. Okay, I see the question as well. I was happy to hear the questions in voices, but yeah, anyway. So would there be relation between containers and Git? So what happens is that containers and Git doesn't have any relation actually. So Git is simply a tool which does the versioning of your code, and it has nothing to do with the container. And container is something which would either have a code or either it will have executable configuration. Containers can have anything. It can be code, it cannot be code. It can be simply a file which can be which can be started right away. Like for example, let's say you have in the Linux, you have some sort of commands, right? Let's say ncat or things like this. There are different kind of commands which you can start a service, do thousands of things. So those all images of, or you can say executable, although of those commands can be present in the container. And there is no relation between Git and containers, by the way. I hope I'm clear. Okay, going forward. Now, let's say we have images, we have containers. Now there should be there has to be something which would, start a container. And this is another real life example. So let's say we have a lot of racks in the kitchen. Okay, where would you put the container? It may be the case that one of the rack is full. Okay, one of the rack you would want to categorize. Okay, I want all pulses at one place, all the tea kind of things at one place. Or if you want to make a specific disease, you want to categorize it, right? There could be another way to keep it as well, like the one which get expired soon. XYZ, you can have any kind of algorithm behind it. But the question is that where would you put the container, right? The same thing is taken care in the cloud world is by Kubernetes. So Kubernetes take care of that. I have to run this container. On which machine I should run this container? So Kubernetes is something which Kubernetes is an orchestrator, which orchestrates containers on one or more nodes. Typically, it's a big number of nodes. Nodes mean machines on which the containers are running. Right. In simple words, Kubernetes ensure that the containers are running in a specific environment. Environment means that whatever the configuration, there are pods which has specific configurations to start the image with, and that becomes container, set of containers. The pod is a set of containers. And as asked, so in Kubernetes, everything you declare that this is what I want. This is the configuration of my pod. This is the configuration of service. This is the service configuration of deployment. Replica said XYZ. So you tell that this is what I want, and Kubernetes will make sure that this will be started as you have mentioned in the configuration file or the YAML file. So that's what Kubernetes does in a very high level. So let's talk a very high level overview of Kubernetes. So Kubernetes have, as I said, it has set of nodes. There's one master node, and there can be n number of worker nodes. So master node is something which has API server, the controller, scheduler, etcd. I'm going to talk about these as well, of course. So API server is something which accepts any kind of communication from either kubelet or users. One thing Kubernetes makes sure is that whatever the request coming from either user or from kubelet, I'll talk about kubelet what it is. So this will be communicated through and REST APIs. So API server is a REST API server which accepts the communication or the commands or from user, developer, things like this. And what controllers are, I'll talk about scheduler first. So scheduler is something we just spoke about, where to schedule the pod. Okay, let's talk about pod as well before that. So pod is the minimal unit of the Kubernetes. So pod is something which will have a set of containers, and they will be running on a one machine. So that's a unit in Kubernetes. Typically, pod has set of containers, and those containers will have some set of process. And typically, those will be a process which starts a server. It can do a job as well. There are different kind of pods, but typically they are processes running inside containers. So what scheduler does is it takes the pod, reads what are the configuration that user has provided, and it schedules it to one of the nodes. It will say that this pod is going to be scheduled on this particular node because this node has enough memory to schedule this pod. And to provide those memory and CPUs, pod configuration has something called affinity anti-affinity. What this specifies that this pod requires worker node to have this much of memory or CPU, or it can have other kind of configuration that I don't want to place this pod on this node where the node has a label equals to something something. Okay, I'll not talk about details. I see that we have various, but this is what scheduler does. Controller does is that how many replicas of they are different kind of controllers. One of them is replica controller, and they're so controllers make sure that how many replicas of that pod will be running to make sure to ensure that certain load is achieved. HCD is the data store. All the resources of Kubernetes, resources means that pod, this controller, scheduler, these all are the resources, and they are stored in a database called HCD. So that's where the source of truth comes from for master node. And kubelet is what it connects with the master node to receive to and fro communication. So API server connects and the kubelet has communication. It's an end-to-end encrypted communication. MTLS, if you have heard of mutual TLS. So it's a two-way authentic. Not of course two-way, but it's have a mutual. So both the API server and the kubelet verifies each other. So what kubelet does mainly is that it connects with the API server and receives the configuration, what it need to do, which pod it need to start, and all and all. And each of the worker node has container runtime. It can be Docker, it can be Podman, and there are other kind of runtimes as well. So Docker is the common one. So Docker is a container runtime which starts container on your machine. Since this is running in a Kubernetes environment, this will be managed by Kubernetes. The kubelet has a connection with Docker to fire up the Docker APIs or Docker calls to start a container and so on and so forth. Kube proxy or network proxy is something in which you facilitate. There are different kind of pods, and pods have different addresses, or and how these will be converted into services so that end users can reach to worker node is what kube proxy does. And there are other kind of add-ons like DNS and CNI plugin and so on and so forth. I'm not going to go in detail about, but I would be happy to accept the questions for this. Or you can read it online. If you just Google about Kubernetes architecture, you'll find tons of examples or things like this. So let's also talk about one of the places where containers are not so good. So of course you will not put jewelry in your containers, right? Because it's very costly and you would not like to compromise that, right? So that's where virtual machines come in picture. Virtual machines provide much better security than containers. Security in the sense they are in an extreme isolation with each other. Even the OS operating system is also isolated. In containers, the operating system is shared. In virtual machine, they are not shared, but they have different kind of drawbacks. I'm going to talk about it. So of course, when it comes to scalability and all, if you keep on spawning hundreds of virtual machine, you will have to pay a lot. Pay in the sense that it will be consuming a lot of storage, of course, the size, and the CPU utilization will be very high, the RAM utilization will be very high, and the cost of running those applications will be very much. And so what happens in VM is that hardware infrastructure is same, and there's a underlying OS, the host OS, and then there is a hypervisor which starts or spawns the virtual machine. And then there is a OS, and then each of the application has their own OS itself. I mean, you can have Windows and Linux running on the same machine with this virtual machine based approach. But that's not very ideal when you run into cloud. In cloud, what happens is that you have an application that has some certain set of library and dependencies, but not the OS. So what makes container very good here is that it is very lightweight. Lightweight means that because it doesn't have OS and things like this, it's very lightweight, and that's why it boots up very fast, because it doesn't have to take care about different kind of hardware initialization or things like this, even virtual hardware. So those containers does not care at all. And since OS is not part of container, the size requirement is very less. The VM sizes are in GBs, where the container sizes are usually in MBs. And again, the CPU utilization is very less, RAM utilization is very less, and hence container is very, very, very scalable as compared to virtual machines. And that's why we use containers in our cloud environment. Okay, so we spoke about cloud workloads. Of course, we need to keep them protected as well. So there are different ways how we can protect it. So there's something called static analysis. So static analysis comes in the very first phase into of the CI pipeline that we spoke about. So it does this image scanning. Image scanning means that it will scan the image whether this is having any kind of misconfiguration or not. Vulnerability scanning, what kind of applications are being used, what libraries, which all vulnerabilities are present. So those scanning. Malware scanning, if at all the image has any malware. Malware is something which starts with application, and it can be anything malicious, which can send your data to anywhere outside, or it can use it for crypto mining and XYZ. Secret detections. This is also one of the important aspects. That's sometimes people leave the secrets in the image itself, image files or image configuration, and if these are present and there's images shipped outside, people will know what are the secret. Let's say AWS secret, they will know, and it's very it can be compromised. So it's very important to have those secret detected in early phase. Of course, I spoke about image misconfiguration. So image misconfiguration, like for example, container should not start with root, for example. So this is a kind of misconfiguration if somebody has written that. Those all should be detected in early phases. Second is the runtime protection. Runtime protection is that when the containers is actually running into the production cluster, what all things we need to make sure that this will not be breached. So there's something called syscall based sensor, network profiling, executable profiling. I'll talk very briefly about it. So syscall, so whenever applications start, it makes a syscall to the kernel to do certain things, right? And based on those syscalls, what we can do, we can see what the application is actually doing, and then we can bring a behavior that this is what the application is doing. Is this behavior or a set of behavior? So that's where the machine learning comes in picture. So those behaviors are sent to cloud, and it may, or there is a machine learning which is running on can be run on the sensor itself, on the container. So sensor can run as a sidecar of that container. So we'll be talking in detail about this, but just keep it very simple and short. Is that application make the syscall, and based on syscalls or a set of syscall, we can find out whether the action that application is doing is malicious or not. Network profiling is that which all connection that the containers makes. Executable profiling is that which all files are present, which all files are used actually to start the application. And profiling means that I'll be talking profiling about it in the next slides. Posture management is also very important. Let's say you have an EC2 machine in your cloud, and you have left and all the firewall rules are blank, and you have left the port open and so on and so forth. So those are the misconfiguration. You should avoid that. And of course, misconfiguration is Kubernetes. Let's say you have a pod which is starting the containers with root by pod configuration itself, or you are mounting a host directory to the container, host root directory to the container. Those are really those can lead to a breach very easily. So those misconfiguration has to be detected. So this is what the posture management is. So so that's what I spoke about, that the protection should be across all the stages, right from the CI time to the CD time, continuous integration to the continuous delivery. I'll be going a little more faster now. So you code, you build, you test, release, you deploy. We have already spoken about these all things in the previous slide. So these all the security has to be in place in each of the stages. And once you deploy, you have to operate, monitor, and plan, and this cycle goes on. And that's what the continuous security and compliance comes in picture. So each of the stages should be protected with either the static analysis or the runtime protection, and also of course posture management. You would have heard of shift left, but you would not have heard of shift up. I'll be talking about both very shortly, of course, because we have very less time. So shift left is that all the security things has to be all the security has to be taken care in the early phases of the deploy or the life cycle. So during version control, you can have the security that my application should not have any kind of code which leads to a breach, which leads to server-side code execution or things like this. And the build time, I'll check whether the image has any issues or not. So this is where Jenkins or Bamboo can come into picture. So this will trigger some image scanning in their pipeline. They will make sure the image is good. The registries, we do registry scanning as well. I mean, registry scanning means that you can have the registries in Docker or Azure or any places. And those registers have, whenever an image comes into picture, a new image, let's scan it and ship the results. That this is the problem with the image, and let's mark that this image should not be used into one of the containers, and we can deploy it. So shift left means that before runtime, we are protecting it. And there is something called shift up. Shift up means that let's say we have been talking about security, so we secure physical machines, visual machines in the cloud. So physical machine as actual host, virtual machines are the VMs that we already spoke about. But there is something called container runtime. Container runtime means that all the runtime protections, and of course on top of which there is FAS. We would have heard of Lambda, AWS Lambda. So we have to protect that as well. Many times those are just skipped, but they are also one of the part where custom written application is being executed. So those has to be protected as well. So that's where the shift up comes into picture, that we are trying to protect the application level security. All the container runtime, I mean, with the help of sidecar and with the pod. Sidecar is something which runs in parallel with a container as a separate container itself, and it keeps on monitoring what other containers are doing. And of course, for that, process namespace is shared so that it can read what all processes are running in other containers and what all other processes are doing. So that's where the sidecar comes in picture. And it monitors the behavior, and it prevents whenever something malicious is happening. Again, function, when I talk about FAS, the AWS Lambda and all, it also makes the syscalls, and underlying they also run on a container itself. And this is where the application level security come into picture, and that's what the shift up is about. Okay, I'll talk about very briefly about the runtime protection, which is profiling. It's a very general technique. We have been talking about it. So profiling means that I will profile the application for, let's say, 10 minutes. What all, let's take a very simple example, files, executables. So which all executable has been used to start the application. It can be, let's say, executable 1, 2, 3. Let's say 3 application has been used. Okay, and next 5 minutes we'll see whether there is no any executable has been used. Okay, so only 3 executables has been used, even though there are hundreds of executable present in container, but only 3 are used in first 10 minutes, and that are very sufficient for the application to start with. Now, whenever let's say a new executable come to picture after 10 plus 15 minutes, we have seen that there's no other more than 3 executable has been used. But suddenly after, let's say, half an hour, we see that, okay, there is a new executable came into picture, and that syscalls for this executable is something which we have never seen. In that cases, it is most probably malicious. That's where the breach is going to happen, and that's where we need to prevent it. So this is a very general technique of runtime protection, which is called profiling. It can be applied on syscalls, network connection, executables. There can be other ways as well. There are other tools which provide these, like AppArmor or things like this. So they will provide these all by default. I mean, they will have set of profiles that you can apply directly based on the standard techniques. If you Google about it, you will get to know. Okay, so let's talk about questions. Okay, I've already answered all the questions, so I hope we are good.
Yes, yes. It was a pretty revamping session that you had. Thank you so much, Mr. Ramesh, for this wonderful session.
Thank you, Ritvik. Thank you so much for having me. And of course, if we want to dive into these all things, we are welcome to go through this. And of course, last and not the least, there is a very deep dive into security, which is coming up tomorrow by Ajit Dumale. To attend that as well. That will give a very dive deep in the security aspects of all the cloud workloads.
Sure. Do leave your email so that people can contact you.
Oh, okay. Yeah, so that's code of node@gmail.com. Okay.
Cool. I'll let you know. Sure.
Okay.
Thank
you. Have
you.
a good day
Thank you.
and weekend, everyone. Bye-bye. Thanks for having me.
You too. Thank you.